Hey guys, I just pulled up on a preventive maintenance and I thought I would get y'all to tag along because part of the job of a preventive maintenance is to find any problem that may cause a breakdown, not just clean the coils and add algae tablets. So here we go, let's see what we find. Alright, we're up in the attic. I just pulled the disconnect so we can check this. Holy smokes. That right there, that's not supposed to happen. You can pull up on it and make it thump, but back and forth like this, there should be no play. Let's make sure we don't have power. No power. You know what? I can't hardly read that. 10 UF. 10 microfarads. So I gotta check that again. I had a little trouble seeing it. 8.6 microfarads. I'm fixing to turn on the blower and see what happens. Let me see, motor 2.9. 2.84 amps. That is almost out of range at 2.9. But y'all saw that, or y'all could hear that the bearings were moving. I'm fixing to open this back up and check that again. Okay, outside everything was running. The contactor was pulled in. Contactor looks clean. That's supposed to be a 55 and 5. Let's check it. Alright, yellow goes to Herm. Nope, yellow's my common. Blue's to Herm. And brown to my fan. Alright, let's see what we got. $48 and 4.97. I gotta check that 40. Y'all forgive me, I oftentimes have to do that. 48.05. All right, we're gonna plus or minus. Hold on, I can't read that. Let's see what that says. Oh, that's 50-60 hertz. Dual voltage. Here we go. Plus 10 minus 5%. There we go. So let's do 50 times 0.95. So the capacitor is still within range. That felt a little bit loose. I worked for another company and I was sent out to replace a compressor that somebody else had diagnosed. And when I went to start it up, the compressor wouldn't start. And come to find out, that's the problem the previous compressor had. So I did a little digging, and the reason the compressor would not start was because this wire right here was loose. The wire coming from the contactor to the capacitor was just loose and it wouldn't start. So in that case, it was a compressor that was replaced that did not need to be replaced. I'm going to do the same thing with this motor that I did with the other one. Speaking of that blower motor, I've seen blower motors fail with less play in them than that. I'm not feeling anything. Let's see if we can reach down in there and get most of that. Most of that cleaned out. That's a clean bowl. If a coil don't, sometimes if you have a double layer coil, it won't do that. Advantages to cold leads after this, as clean as it was. Is less likely to rust out. I'm going to show y'all an issue with this field piece app. That pressure is correct, but that saturation or evaporative temperature is not. That right there should be close to freezing. So let's check it on Measure Quick. Okay, here we are on Measure Quick. Similar pressure, but look at that temperature, 27, 28 degrees. Yes, it's kind of cool at 71 degrees inside, and it's cool out here, but that right there seems kind of low to me. And here you see superheat is high. This does have a TXV on it. Subcooling is also high. Now some of the higher efficiency systems do have a high subcooling. This one's about 14 years old, R22 system. We're reading 9 amps on the compressor. And 0.8 on on the condenser fan motor. After watching this for a little while, my superheat has come down to 2.6. Subcooling is still kind of high. Low superheat, high charge, high subcooling, high charge. I ain't fixing to try and adjust this right now because it's cool out here. So that was just basically a preventive maintenance. It goes to show that if you're thorough, you can generate work for yourself and more income. I did get the job for that blower motor, and when I replace it, I will likely post a link at the end of this video. So thanks for watching, and I will catch y'all on the next one.